Okay, Unit 10, Day 1, your homework prep here. You can see that the first 8 problems here are some review. So I want to just review real quickly what it is that you're supposed to do, and maybe even work a couple problems with you. Take a look at Roman number 1, where it talks about multiplying monomials. And take a look at the example here. 6y to the third times 3y to the fifth. Now, think about some of the questions that I asked you guys earlier in the year. And one of the questions was, I would say, do you see any additions or subtractions in that problem? And y'all would say no. So then I would say, well, how many terms do you see there? And since there is no addition and no subtraction separating anything, that is just one term, or that is just one big multiplication clump. So what that means is I can basically drop these parentheses, and I can rearrange these pieces any way I want to. And you can see I put the numbers up in front, and I put the y's at the end. Well, I treat the normal numbers normally, so 6 times 3 is 18. And then I have to think about my exponent laws. If I've got y to the third and y to the fifth, I'm going to take the 3 and the 5 and add them and get y to the 8th. Okay, let's do number 2 together. I've got 3m into the second times n into the second n. And I'll ask you the same questions. How many plus or minuses do you see in there? You don't see any. How many terms do we have there? Not 2, 1. Okay? There's one big multiplication clump, which means I can rearrange these in any order that I want to. So, okay, all the numbers up to the front, all the m's second, and then all the n's, the Nancy's, third. Okay. Also, don't forget that on this m, this is into the first, and that's into the first. Okay. So let's do the normal numbers. 3 times 9 is 27. Then we've got m to the first times n to the second, so that's m times m times m. That's m to the third. And then we have n to the second times n to the first, that's n to the third. Okay, let's talk about the second group here, down here in letter B. We have a monomial times a polynomial. Okay, and you can see the example here that we have a 4, that's the monomial, times a polynomial. It's actually a trinomial. There are 3 terms here because you have a plus and a minus separating those terms. And what we have to do is distribute here. So the 4 has to multiply by all those terms. You can see 4 times 3x squared becomes 12x squared. 4 times 4x becomes 16x. And 4 times negative 8 becomes negative 32. Okay. Of those 3 terms in your answer, none of them are like terms. An x squared cannot be added or subtracted to an x, which cannot be added or subtracted to an integer. So we're just stuck there. That's the end of our answer. Let's work number 6 together. On number 6, we have another monomial, like the 4, except it's 6pq. Now notice both the p and the q are to the first power. Okay. And we're going to multiply that times the binomial, 2p to the first times, minus q to the first. So what we're going to end up doing here is distributing, a little hippity-hoppity. And on the first one, we're going to do 6pq times 2p. Okay? On the hoppity, we're going to do 6pq times minus q, or negative q. Okay? So we'll treat the red, the hippity part, as one problem, and then we'll treat the hoppity part is another problem. And there'll be 2 terms in our final answer. So let's take a look at the red. We could rearrange these in any order because there's no pluses or minuses in here. So 6 times 2 times p times q. All right, 6 times 2 is 12. P times p is p squared times q. We will get 12p squared q. Okay. For the hoppity, I could rearrange this, guys. Notice here 6pq times minus q. Think of that as a negative 1q. And if you think of that as a negative 1, then you can take the 6 and the negative 1 and put them together and not have to worry about that negative sign. Then we got our p's. Then we got our q's. So 6 times negative 1 is a minus 6 times p to the first. And then q times q gives us q squared. So we'll get minus 6p q squared. Okay. Hopefully that'll help you a little bit with the examples and the ones that I did here on number 2 and number 6. I can help you with some of the others. And of course, if you have any problems with those, come and see me. Okay. Now let's get into the video part, because this is what's new. What happens when we multiply polynomials times other polynomials? And you can see in your first example here, we have x plus 3, which is a binomial, times x plus 2, which is another binomial. So we have a 2-termer times a 2-termer. Okay, well, there's a couple of different ways I'm going to ask for you guys to do this. and then you guys can choose your preference. First is called the distributive method. And what it basically says is this. Every single term that's in the first binomial is going to be distributed to every single term in the second binomial. So it's like a distributive method where you'll distribute the x, and then you'll distribute the 3. Okay? So let's see what that looks like. Here you have x times x. This is the red hippity. That's x squared. Then you have x times 2. Well, that's just 2x. That takes care of the red. Now let's distribute the 3. 3 times x is 3x. And then lastly, 3 times 2 is 6. If any of you guys have ever done FOIL before, that's what we just have done. If you don't know what I'm talking about, don't worry about it. This is called the distributive method. Okay? Now, before I box this up and say that I'm done, there are some like terms here. There's a plus 2x and a plus 3x. These guys can combine. So we end up with x squared plus 5x plus 6. Okay? Now, with a 2 by 2, you'll see me use the distributive method a bunch. But there is another way that's got a little bit more structure. And it involves Punnett squares. Or you might hear some teachers call it a graphic organizer. Okay? Well, if you're going to multiply a binomial times a binomial, and you're going to make your Punnett square your graphic organizer, you got to make it fit how many terms you have in each one of your polynomials. So if we have a binomial times a binomial, we need a 2 by 2 square. Okay, so let's make a 2 by 2 square. Then you dress or set up, just like you would in science with your recessive and dominant traits and so forth, you dress the Punnett square with the terms that are in each binomial. So like x plus 3 is your first binomial. It doesn't matter whether you put it on the top or the bottom, but you have x and 3. X plus 2 is your second binomial. You'll dress the other part of it as x and 2. Now notice since all these parts are pluses, they're positives, I have all positives up here. If there was a minus in there, I would have a negative. Okay. Here's the rule. Write this off to the side. Write multiply to get in. Then write add to get out. So to get into the box, we've got to multiply. To get out of the box, we've got to add. Okay. Now what you're going to see with the structure on the right side is going to be very similar to what we just did with the distributive method. Now let's say that I want to do this box right here. To find out what goes inside that box, I have to look outside and see that the 2 x's are what's going to control what's inside that box. So to get inside there, I'm going to multiply x times x and get x squared. For this box, you can see that you're going to have a 3 and an x. So 3 times x gives us 3x. Down here, we'll get 2 and x, 2x. And on the last one, we'll get 2 times 3, which will give us 6. Now notice, these 4 terms inside the box are the same exact terms we get over here on the left with our distributive method. So it's the same thing. It's just you're using more structure. To write your final answer, you're going to add to get out. The only ones that can add together here are the blue 2x and the green 3x. They're like terms. So just like the one on the left, we're going to get x squared plus 5x plus 6. So it gets you to the same spot. What you guys have to decide is, do you want the added structure or not? Okay? Let's do a couple more examples. On number 2, let's say you guys get something like this. You got a binomial, x minus 4, and we're going to square it. Now, I'm going to start this problem off early because there's a lot of students who struggle with this. I want you guys to understand that this is not the same thing as minus 4x squared. Okay, these are not the same thing. The one on the right, the red, is just one term. There's no additions or subtractions. Yes, there's a negative, but there's no additions or subtractions to separate that. That's just one big term. You would just square everything inside there. But the one on the left there, the black one, has a subtraction. There are 2 separate terms there. So we can't treat it the same way. So this is not going to be equal to x squared plus 16. It's not the truth. It's not the same thing. You're going to see why here in a second. What we have here is we have a binomial, x minus 4, times itself. So x minus 4 times x minus 4. So to find this answer, we had to either use a distributive method or your 2 by 2 Punnett square. Usually when there's just binomials, you're going to see me resort to the distributive method. In other words, I won't take the time to draw the box. All right, so let's see. X times x is x squared. X positive 1x times a negative 4 is a negative 4x or minus 4x. Now let's do the blue. Minus 4 times x is another negative 4x. And then the last term is negative times a negative. That's a positive 16. Now, remember a moment ago I said that this was not going to be equal to x squared plus 16. But those parts are there. There is an x squared, and there is a positive 16. The difference is that there's those middle terms. So as we begin to add and subtract like terms, we have x squared, and then we have negative 4 and negative 4. They're both pulling in the negative direction. That's minus 8x plus 16. So it's that middle term. It's that minus 8x that's the big difference. Okay, let's do a couple more examples. Number 3 here. Let's say that I have 8m squared minus n times m squared minus 3n. Okay. Once again, another binomial times a binomial. When there's only 2 terms in each one of the parentheses, I'm usually just going to do the distributive method. I'm not going to worry about drawing the box. If I get up to 3 or more terms inside the parentheses, then I usually will draw the box because then it gets a little bit more crazy. Okay? All right, so let's distribute here. I've got 8m squared times 1m squared. All right, so 8 times 1 is 8. M squared times m squared is m to the 4th. Red hoppity. 8 times negative 3 is minus 24. Then m squared times n to the 1st is just m squared n. All right, green. Negative 1n times m squared is negative 1, or just negative. And then I'm going to write this as m squared n instead of nm squared. I'm just going to make it alphabetical. Okay? What also is going to help me out here in a second is these guys are going to be like terms. Okay, that's just a reason why I wrote that in that order. Okay, last one. Negative 1 times negative 3 is a positive 3. And then n times n is n squared. Okay, so let's finish the problem by adding and subtracting those 2 like terms in the middle. I get 8m to the 4th. Now, negative 24 and negative 1 are both pulling in the negative direction, so that's negative 25 m squared n's. And then plus 3n squared. You guys might have some questions about the term in the middle. In other words, why didn't that become an m squared into the second? Well, remember, on the top part, when we're doing the hippity-hoppity, we're multiplying. So when you multiply, you're going to end up changing the exponents on those powers, okay? When you add and subtract, you're just collecting like terms. You're just saying, how many of those m squared n's do I have? All right, last one here, number 4. And I'm going to kind of hog up most of the room here. Y'all can write a little bit smaller. I'm going to have a binomial, x plus 3, times a trinomial, x squared minus 4x plus 6. All right, now notice in that second parentheses, I have 3 terms. If it starts to get that large, now I'm going to go to the box for structure. Okay, so I have a binomial, which is a 2-termer, times a trinomial, which is a 3-termer. So the box that I'm going to make is going to be a 2 by 3 box. Okay. Now I dress my box with the terms that I see. The 2-termer obviously has to go here, so here's x and 3. The trinomial is obviously going to go here. Notice the negative I put for the 4x because it's being subtracted. Now I'm going to multiply to get in, add to get out. Okay. X times x to the 2nd, that's x to the 3rd. X times negative 4, that's negative 4x squared. X times 6 is 6x. All right, let's do the 3. 3 times x squared is 3x squared. 3 times negative 4x is negative 12x. And then 3 times x is 18. All right. Now let's add to get out. So I'll be looking to see which of these terms are like terms, which can be added together. Well, those are x squareds, those can go together. And those are x's, those can go together. So let's see what we got here. I have an x to the third to start off with. And then 3 minus 4, I have a negative 1x squared. And then negative 12 and 6 gives me a negative 6x. And then there's the 18 at the end. That is the product of that binomial and trinomial. Okay. Come to me with the questions before you guys turn this in. Make sure you do the practice problems at the beginning. I hope you guys have a great weekend, and I'll see you soon.